So up to now, are you people clear? Like what is a coverage, code coverage, functional coverage, and some questions related to those coverages?
Yes, ma'am.
Okay. So now we'll look into how to write a functional coverage. So what are the things you need to write a functional coverage? Okay. So in order to write a functional coverage, you need a cover group, a cover point, and if you want a cross coverage, you can also mention that one. Okay. Cover group, cover point, bins, cross coverage. All these things are needed for writing a functional coverage. Okay, so we'll see one after the other. So coverage model is defined using cover group construct. Okay, so when you are writing any coverage, the main keyword to write a coverage is like cover group. Okay, inside the cover group only, you will be writing cover points, and in the cover points, you will be writing the bins. Okay, the hierarchy will be like that. So the cover group construct is user defined type. Okay, we will be defining our own cover group. It's not predefined one. Cover group is the only keyword we were just using. Okay, it's not like a predefined one. We were defining it. So the type definition is written once, and multiple instances of that type can be created in different constructs. So it's also simple like class. Okay, so when you are writing a cover group, once you declared a cover group, you can make so many instances of that cover group, and wherever you need it, you can use those instances. Okay, like how we are defining a class, and in different classes you were using instances of that classes, right? So in the same way, cover group also you can use in that way. So similar to a class, once defined, a cover group instance can be created via the new operator. So how we are creating an instance of a class, in the same way you can create the cover group instance also. Okay, so this cover group, where you can write it, you can write it in a module block or in a program block or an interface or inside a class also you can write this cover group. Okay, so each cover group specification. So what does, like inside the cover group, what are the things you will be having? Okay, so clocking event that synchronizes the sampling of coverage points. So as I already told you, you will be writing a cover group. Inside the cover group, you will be writing cover points. So cover points are nothing but your signals. Okay, for all your signals, for each and every signal, you'll have a cover point. Let's say you are having 10 signals, for 10 signals, you'll have 10 cover points. Okay. So in order to sample all these cover points, you'll require a clocking event that is like at passage clock, like that. Okay. A set of coverage points, the cover points, and if you are mentioning any cross coverage, I'll explain you when it comes, like in the upcoming slides. Okay, so if you want to mention any cross coverage, that also you can mention, and optional formal arguments will be there if you want. These are optional formal arguments. Coverage options are also optional. Last two were optional. Up to here it has to be there. Means cross coverage, if you need to write a cross coverage, then it should contain. If you don't need to write a cross coverage, then it's not necessary. Whenever you want to write a cross coverage, you have to define it in a cover group only, not outside the cover group. That's the thing. So cover group example. So now see, so here I'm having two types of cover groups, like two examples. So cover group is a keyword. So this is my cover group name. This is my clocking event at passage of clock. So inside this is my cover point name, like label. Okay, so this is my cover point name label. Cover point, you were using the keyword, and for which signal you are writing cover point, you have to mention that signal here. A. The signal is A here, so that's why. For A signal, you are writing a cover point, and you are ending this group. How to create an instance for this cover group? So your cover group name. For the cover group name, you are creating the instance. like object. Okay. By using this only, you can activate this cover group. Okay. So how to activate that means like two ways are there. So here, if you just simply write like this, with the help of this event only, this cover group will get executed. Another way is like you have a sample method that you have to trigger it. Means you have to call that sample method. Okay. So how you will call? So after creating the instance of your cover group, you have to call like this, that instance name dot sample. If you write like this, it will get called. So this you have to write inside the run task. In your system Verilog environment, you are having run tasks, right? All the run tasks will be run parallelly because we were mentioning each class, each run task inside the fork join block. So this you have to place it. The sample method, if you want to write, you have to place it inside the run task. Okay. So this is how you will be writing your cover groups. So how many signals you are having, for how many signals you want to write the functional coverage, that many cover points will come. Clear? So cover points. So cover group can contain one or more cover points. So cover point can be an integral variable or an integral expression. So cover point can be a variable or an expression. Variable means like in the previous thing we have seen here a variable, right? Instead of here, if you want to give an expression also, you can write an expression also here. Okay. It's like either a variable or an expression, integral expression. Okay. So each cover point is associated with a bin. As I already told you, we have to write a cover group. Inside the cover group, we'll be writing a cover points. And inside the cover points, we'll be writing bins. Okay, so the hierarchy will come like that. So on each sample clock, simulator will increment the associated bin value. Okay, so at every passage of clock, your simulator will increment the bin value, associated bin value, it will increment. So this bins, you can like, it can be created or bins will be automatically created, or if you want, you can create them explicitly also. So how you can create them, we'll see now. Automatic bins or implicit bins. We are having two types of bins. One are automatic and or implicit bins. Another one are explicit bins that they will be writing. Automatic bins, you are not writing anything. Those are created automatically. Okay. So automatical bins means, let's see here. So this is your coverage. Here in this, you are having clock, 8-bit address, single bit WR underscore RD signal. Okay. So for address and WR underscore RD, you are writing two cover points. Okay. So here 8-bit address means 2 power 8 combinations you'll get. So what is 2 power 8? Means 0 to 255 values can be generated by address. Right. So these 2 power 8 means like 0 to 255 values, you can check by writing bins explicitly, or if you just write like this, automatic bins were created by the tool itself when you're simulating it. Okay. So for n-bit integral cover point, 2 power n number of automatic bins will get created. Okay. So if you are having like 8-bit, so 255 automatic bins means for each and every value, a single bin will be created. Clear?
Yes, ma'am.
So as this is a single bit signal, you will be having only two values, either 0 or 1. So two bins were created for the single bit signal. One bin for 1, one bin for value 0. Okay. Explicit bins. So explicit bins means we were declaring those bins. Okay. So how to declare those bins? By using bins keyword. By using bins keyword, we will declare those bins. Okay, explicitly for a variable. In automatic bins, separate bin will be created. Like for each and every value, a bin is created. Whereas explicitly, you can have a bins with a range. Okay, so I'll show you an example. See here. So you're having an 8-bit address, right? In the previous example, you have seen, you have not mentioned any bins explicitly. So automatically 2 power 55 bins will be created for each value. For 0 value, 1 bin. For 246 value, 1 bin will be created. So it would be like that. So apart from that, you can also write explicitly. Bins you can define explicitly. How you have to define? So inside the cover group, inside the cover point, by using flower braces, you have to create your bins. Okay. So by using bins keyword, so here I am giving the label for this bin. So it is B1 equal to, you are just giving only 3 values, 0, 2 and 7. Okay. And see here I have created so many bins for this. So each having some sort of value. So what does it means? Like now B1, like when you simulate this code, your bin will get incremented for address from 0, next 2 it will come, and next 7. When you are writing like this, B2 of 3, so it means it creates 3 bins with the ranges 11 to 20. So B2 of 0, B2 of 1 and B2 of 3. So all these 3 bins will get values in between 11 to 20. So distributed 11 values will be there from 11 to 20. All those 11 values were distributed among all these 3 bins equally. Okay, so in this way they have distributed. And if you are simply writing like this, so bin B3, it should be like in the range of 30 to 40 and 50 to 60 and 77. So it B3 gets increments for address. So when it is 30 to 40 and 50 to 60 and 77. So if you are mentioning like this, here you are not mentioning any number, and here you have given. So it will create automatically according to this, it will create 3 bins, B4 of 0, B4 of 1 and B4 of 2. It's not 3, it's 2. And it will assign all those things respectively. Okay. And yes, it will also create automatically 3 bins, and for each bin it will assign the value. So if you are writing a dollar symbol, means let's say you are having a 48 bits of data. 2 power 48 combinations means you can't write everything explicitly. So in that case, you can simply use this dollar. So it will take the maximum value, maximum signal value it will take. Okay. So these are like different ways to write bins, but generally how few people or how we'll write is like, for easy understandable purpose, cover group, CG is my cover group name, at passage of clock. Okay. So C1 is my cover point. For the same example I'm writing, cover point keyword I have to use for address signal, bins, bins B1 equal to 0 to 7, and next bins B2 equal to 8 to 15. To 63. So in this way, we were writing the combinations up to 255. We are splitting those combinations. Okay. 164 to 127. You're closing this thing. Okay. And for cover point C2, as it is like only single bit signal, you can write like this. So in this way, we will write our cover groups. Okay. In another way also you can write like the same thing, C1, cover point address since B1. In this way also you can write directly also by using a single bin you can give, or you can split your bins. But the most recommended way is like to split your bins. Why? Because if you remember in your system Verilog environment, you were using a repeat loop. 10 times or 20 times you are repeating your design, right? Everybody remember that thing?
Yes, ma'am.
Repeat of 10. So if you are using like only you are running your design only for 10 times, okay? So when you are writing this only single bin for this, so you'll get 100% functional coverage, okay? So when you are splitting your bins like this, and when you are running your design only for 10 times, you'll not get 100% functional coverage. Can anybody tell me why?
Don't know, ma'am.
Okay, so if you are writing a single bin for the entire combination, if you are repeating it for 10 times or 100 times, this cover point will get 100% coverage. Whereas if you are splitting your bins and if you are running only for 10 times, you will not get 100%. Why? Because in that 10 times, you may get values. Like here you are having 6 values, right? From each bin, let's say like at first repetition, repeat of 1, I'm getting a value of 6. At repeat of 2, I'm getting a value of then 18. And for repeat of 3, like that 10 times, here only 10 values I'll be getting. So here the maximum hit for the bins were not maximum. Only a single value was hitting. So you'll not get 100% coverage. Whereas here, if you write a single cover point like this, 10 times you are repeating means all the values are between the range 0 to 55. But here, all values are not between the range. If you are getting 6, only this bin will get hitted. Remaining all bins will not get hitted. It will also 0% coverage. Only this will show some 50% coverage. So only this bin is hitted, remaining all bins will not be hitted because the value lies only in this bin, in this range only. So because of that reason, if you are splitting your bins and if you are running your design only for minimum number of times, that is for 10 or 20, you will not get 100% functional coverage. Okay. So in order to get 100% functional coverage, what you have to do is like, what is the maximum number of your thing? That many times you have to repeat your design. It means like here I'm having 255 as the maximum range. So repeat of 255. If you give 255 times, your design will get simulated. It means 255 values will be generated. So all bins will be hitted equally. So you'll get 100% functional coverage. Clear?
Yes, ma'am.
Clear, everybody? Anybody having any doubts? So these are called as bins. These are explicit bins which we'll be creating. But the most recommended way is like, if you write like this only, you'll get to know what are the untested portions in your design. See, sometimes if you are repeating it for 255 times also, some bins, some values may not get triggered due to some delays or something. So then you'll get to know when you observe the coverage report, you'll get to know which bin is not hit. Then you can make some changes according to that report. You can make some changes and again you can run your design. So by this, if you are splitting your bins, you'll get to know what are the untested data values that were not hitted for your design. Okay. So in this way, we can write explicitly, like that way we'll be mostly using in our design. So these are also different ways to write a bins. In this way also you can write. This is an example. You can go through it. Okay. So in the bins also, you are having so many types. Like in assertions, we were having consecutive repetition operator, all those things, right? So here also you are having so many bins, so many types of bins. We'll see one after the other. Okay. So first one, it's like a transition bins. Okay. So what are transition bins like? Transitional functional point bin is used to examine the legal transitions of a value. Okay, it means like, let's say I want to check a signal whether it is transitioning from 1 to 0. Okay, my signal, I have a single bit signal. I want to know whether it is going from 1 to 0 or 0 to 1. I want to check it. So how you will check it? By using this transition bins only, you can check those transitions. Okay. So system Verilog allows to specify one or more sets of ordered value transitions of the cover point. It's not only with the single bit transition. You can also observe the transitions of a vectors also. So these are types of transitions. So those are like single value transition, sequence of transitions, set of transitions, consecutive repetitions, range of repetition, go to repetition, and non-consecutive repetition. Okay. So single value transition is specified as like this. So if a signal is changing from 1 to 0, to know a signal which is changing from 1 to 0 or 0 to 1, a single value change, you can use the single value transition. The symbol is this one. Okay. So if you see the example, so this one is like whether this particular bin, like whether this cover point Y is transitioning from 3 to 4 or not, or whether it is transitioning it from 5 to 6 or not. You are just checking. If it was transitioning, means from 3 to 4, it was, if it was going, this bin will get hitted, you will get a coverage. If it is not, this bin will missed, you will get least number of coverage. So by that you will get to know which point are transitioning correctly. Okay. So this is single value. The similar with sequence of transition. So see like this. So it's like whether the cover point Y is transitioning from, for a sequence of transition means it should transition from 3 to 4. After when it reaches 4, it should go from 4 to 5. Again, if it go from 4 to 6 directly, it will not valid. This bin will not get hitted. So this is the only valid sequence of transition. You are checking only for this sequence of transition. Okay. So this is called as sequence of transition. These are set of transition. See, you can make on the LHS side, you are making a set, and on the RHS side, you are making a set. So what does it indicates is like from 3 to 5, they can be a transition. From 3 to 6, they can be a transition. From 4 to 5, they can be a transition, and from 4 to 6 also, they can be a transition. So only in this 4 types of transitions you can observe. These are called as set of transitions. Clear? Are you able to understand? Hello?
Yes,
Yes,
ma'am.
ma'am.
And these are like consecutive repetitions. So this 3 should be continuously repeated for 5 times. So we were using this. So here, as this is like we were using to generate for each loop to generate the values, and by using sample method, I'm executing this cover group. Okay, that's it. Apart from that, nothing is there. So here it's a range of repetition. So 3, it should be repeat in the range of 3 to 5. Means minimum range is 3 times 3 value it should come, and the maximum range is 5 times the 3 value it should come. From 3 to 5 means 3 times it can come, 4 times it can come, and 5 times it can come. Okay. So here, as we were mentioning, like this, a range of repetition, it can be either from 3, 4, or 5. But as we are mentioning like this, it's a range of repetition. It can only generate values between 3 and 5. Means only 4 times we can get a value. The 3 times if we are getting 3 value, that will be ignored. And 5 times if we are getting 3 value, that will be ignored. This is called as range of repetition. Okay. And this is a go-to repetition. So the symbol is the same way, how the same symbol which we used in assertion. So it's like from any, like from 5 to 3 it was there, means it should not be continuous. If you are using go-to repetition, it means that the repetition of the range is not continuous. Okay. Just a minute. Okay, so the repetition range, it does not contain continuously 3. It should not generate continuously from any of the transaction, either from 5 to 3 or 10 to 3. If any of the transaction from any of the number comes to 3, so that comes under go to repetition. Okay, so it's like this. In between the dots is like any number apart from 3, it can contain any number. Okay, and non-consecutive repetition, it's also the same thing. But I'm not sure like what is the difference, exact difference between go to and non-consecutive. So you have to just go through this non-consecutive repetition and go to repetition clearly. Okay, please note aside and go through it deeply, because I haven't used much and I'm not sure about it. Apart from transition bins, we were having wildcard bins also. Okay, so what are those wildcard bins means? So by default, like in interface, we were declaring each and every signal as 4-state data type. So it can contain values of 4 states, that is 0, 1, X and Z. So if you don't know, like you just want to mention like this. So this question mark can take 0, 1, X and Z, right? So if you are mentioning question mark, so it can take 0, 1, X and Z. So as if you are using wildcard bins, what it will do is like the X and Z values will be converted to 0 or 1 if you are mentioning wildcard bins keyword before the bins. Okay, so if you are having a bin like this and you don't want X and Z values to be generated, it has to be like equal to 0 or 1. It has to be converted to 0 or 1. So then you can use this wildcard bins. Okay, so how to use is like, yeah, if you see this example, the syntax is like you have to use the keyword wildcard before the bins keyword. Okay, so if you are using like that, the question mark symbol will take only zeros and ones, not X and Z. Okay. Coming to ignore bins. Inside the ignore bins, the syntax is like the same, but you have to use ignore underscore bins keyword. Okay, so if you use this thing and if you are mentioning any value to that bin, it means that value is ignored. So when it was hitted, it will not throw you any error. It will just ignore that value. Okay, it does not comes under coverage. It was excluded from the coverage. Okay, by specifying them as ignore bins. If you want some values to be excluded from the coverage, then you can use this ignore bins. Okay, whereas you have one more thing, that is like illegal bins. That syntax is also illegal underscore bins only you have to mention. But the difference between illegal and ignore bins is like when ignore bins were hitted by default, like due to some faulty or something, if ignore bins were hitted, it will not throw you any error. It will just simply ignore. But if in any case by default or due to some faulty in your design, so any of the value which is mentioned in your illegal bin has been hitted to your DUT, that will throw you a runtime error. Okay, so a runtime error is issued when a value is hitted which is declared in an illegal bin. It will throw you a runtime error. This illegal bins were also excluded from the coverage. The only thing is when ignore bins by default or by some faulty, if it was hitted, it will not throw you any error. Whereas if it was hitted by faulty, the illegal bins, it will throw you a runtime error. Clear? Amit, Neha, is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. So this is an example. You can go through it. Cross coverage. So in cover group, we can mention cover points, different types of bins we have seen, so that we can mention inside the cover point, cover group, and cross coverage also you can mention inside the cover group if needed. Okay, so cross coverage is specified between two cover points only. Okay, so between two cover points only you can do a cross coverage, but not between two cover groups. Okay, so in a class you can contain any number of cover groups, but you can't perform cross coverage between two cover groups. You can only perform cross coverage between only two cover points. Why we can't perform cross coverage between two cover groups is like you will be having different clocks for each cover group, so that will not get synchronized. So because of that reason, cross coverage is not possible for cover groups. This is also one of the interview question. Okay, so here the expressions cannot be used directly in a cross coverage. A cover point must be explicitly defined first. So here I have given two cross coverage example, one by using cover points directly. So for two signals, I have used two cover points. So C1 cross C2, these are my labels. You have to use cross keyword C1 comma C2. So this is called as cross coverage between two cover points. So if you want to do a cross coverage between a variable and an expression, so means like between the variables also directly you can do in this way. Okay, by directly writing this a comma b, you can do this cross coverage. And cross coverage between variable and expression also you can do. So before that, for an expression you have to declare a cover point separately, and for the variable you can directly cross it. So a is a variable, bc is your expression, right? So between a variable and expression you can also define your cross coverage. Clear up to here? Any doubts?
No, ma'am. Clear.
Okay. Okay. So these are the most important things. These are like some of the coverage options you can have. Okay. So some will be, if you want me to explain, I'll explain these also, or otherwise If you just read it also, you'll get to understand. Okay, so you have auto bin max, it's one of the coverage option. So default value is 64, only 64 bins can be generated by this auto bin max. If it is more than 64, it will not generate, we have to declare it explicitly. Okay, so these are some of the options you can enable. So how you can means, like here, these are your options. For cover group, if you want this option, you have to put yes. And if you don't want this option for anything, like for cover group, for cover point, and for cross coverage, you can mention. So which option you want for which thing, you can mention by just writing yes or no. So all these options they have given you clearly. So if you just go through it, you will get to understand. That's it. All these things, if you just go through it, you'll get to understand.